watching. So today I will be explaining about a very important mathematical topic, which is mathematical reasoning. So this topic involves a few subtopics. The first is about statement, the second is about compound statements, the third is about implication, and the fourth is about deductive reasoning and inductive reasoning.
All and some are quantifiers. All refers to each and every object or case. Some refers to several object or case.
Every statement has a true or false value. So in order to make this statement a true statement, we have to add in quantifiers which describes quantity, all, or some. So for the first statement, even numbers are divisible by 2. In order for this to be a correct statement, we have to add in the word all, because all even numbers are divisible by 2. For the second question, something prime numbers are odd numbers. So in order to make this statement a true statement, we have to add in some. Why is it? Is that because that 2 is also a prime number, but it is an even number. So that is why we have to say some prime numbers are odd numbers. For the third question, something even numbers are multiples of 2. So the correct quantifier to this question is all, because all even numbers are multiples of 2.
A compound statement is a statement that is a combination of two statements connected with the word and or. If the statement is connected with the word and, then both statements have to be true. If the statement is connected with the word or, then at least one statement has to be true.
It's about compound statements. So you have to determine whether this statement has a true or false value. So for the first question, it says that 3m plus m equals to 4m and 3m multiply m is equal to 4m squared. So because we use that word and, in order for it to be true, both statements have to be correct. But as we see here, 3m multiply m is actually equal to 3m squared. Therefore, this statement has a false value. So for the second statement, it says that 7 is larger than 2, or negative 7 is larger than negative 2. So in order for this statement to have a true value, because we use the word or, only one statement has to be correct. So in this case, 7 is bigger than 2. So therefore, it is true. This statement is true. So for the last statement, 1 over 1000 can be written as 0.1 and 10 to the power negative 2. Because we use the word and this has to be correct. Because both of them are correct, this statement also has a true value.
Implications involve two statements that impact one another. If the first statement is an antecedent, then the second statement is the consequent.
Involve two statements which impact one another. So we have to make an implication based on these two statements. So for the first statement, it states that both A and B are even numbers. So at the second statement states that sum of A plus B is an even number. So in order for this to be an implication, we have to say that if first statement, then second statement. So the answer to this question is, if both A and B are even numbers, then the sum of A plus B is an even number. So from the second question, there are two implications that can be derived. The statement says that A is greater than B if and only if A negative B is greater than 0. So we can derive two implications based on this compound statement. So the first implication is that if A is bigger than B, then if A negative B is bigger than 0. So that's the first implication. The second implication is if A A negative B is larger than 0, then A is larger than B. So implications can also be conversed. So for this third statement, it says that if a shape is a trapezium, then it is a quadrilateral. So if we converse this statement, we can get that if a shape is a quadrilateral, then it is a trapezium. But this does not necessarily mean that this has a truth value, because even though this statement is conversed, the statement is wrong, because not all quadrilaterals are trapeziums. So the converse of this statement has a false value.
There are three forms of arguments in mathematics. For the first form, all A are B, C is A, C is B. For the second form, if P then Q, P is true, Q is true. For the third form, if P then Q, not P is true, not Q is true.
As mentioned, a conclusion of an argument is formed from the first premise and the second premise. So, the first premise is that all rhombus are parallelograms, and the second premise is empty, it only gives a square, and the conclusion of this argument is that a square is a parallelogram. So, as carefully explained before, we know that this is the first form argument. So, in order for it to be a complete argument, we have to say so this is a complete argument. The first premise is that all rhombus are parallelogram. A square is a rhombus, a square is a parallelogram. So for the second argument, they did not give us the first premise. But premise number 2 says that x is smaller than 5, 2x is smaller than 10. So we can build an argument based on the second premise and the conclusion by filling up the first premise. So what we can do is since this is the second form argument, we have to use the terms if then. If x is smaller than 5, then 2x is smaller than 10.
Deductive reasoning is the process of making a specific conclusion based on a general statement.
As mentioned, deductive reasoning is the process of making a specific conclusion based on a given general statement. So this statement is very general. It says that the sum of interior angles of an n-sided polygon is n-2 multiplied by 180 degrees. So the question asks us to make a conclusion by deduction for the interior angles of a heptagon. We have to specify the statement to find the interior angles of a heptagon. So we all know the heptagon has 7 sides. So the specific conclusion of the statement is the sum of the interior angles of a heptagon is 7 negative 2 multiplied by 180 degrees equals to 900 degrees. So a heptagon in general has the sum of interior angles of a heptagon is 900 degrees. So the only thing that we have to do is that we have to substitute the n by using the actual number of sides of heptagon, which is 7. So therefore we get this complete.
Inductive reasoning is a process of making a general conclusion based on a given specific case.
So as mentioned, inductive reasoning is a process of making a general statement based on a given specific condition. So we have to make a very general statement for these specific cases. So the question says that make a general conclusion by induction for the sequence 3, 8, 13, 18. We can see that it gives us here that the variables is 0, 1, 2, 3. So the very general statement that we can make is that this sequence can be written as 3 plus 5n, where n is equal to 0, 1, 2, 3.